Okay, continuing from the last video, we were up to number 8. Okay, so we've got a negatively charged balloon, and we say here that it can attract a neutral wooden stick by inducing a positive charge on the stick's surface. Okay, so induction is where they're not touching, but one object is making charges move around in another object. This question asks, how is charge polarization different in insulators and conductors? Okay, so remember, we talked about objects that are conductors. That's where the electrons move freely through the material. We said a lot of metals are conductors. So those would be, kind of where the electrons can move throughout the conductor's material. And then insulators are like the opposite of conductors. Electrons can't move as well through an insulator. You can charge an insulator. So like a balloon is an example of an insulator. And if we rub the balloon with felt, what's going to happen is that electrons will build up on the section we rub, but then the rest of the balloon will stay neutral. So you'll have like one section that's charged of an insulator. Whereas with a conductor, there's charge like spread throughout because of the material, because the electrons can move more easily through the material. Okay, metal sphere hangs from an insulated thread. How would the ball react to a positive rod and a negative rod when brought close? So again, induction. Okay. So how would they react? How would it react if the sphere is neutral? Okay, so if it's neutral, it will be attracted to either one of those. In both cases, the positive rod is going to induce negative charges to come near to it. The negative rod is going to induce negative charges to move away from it. But in either case, you're going to end up with an attraction because you're going to have a section of this sphere. The sphere is going to become polarized, basically. So it's going to be attracted to either positive or negative. If the sphere is negatively charged, okay, then it's going to be attracted to the positive rod because opposites attract. And it's going to repel the negative rod because like repels. Okay, so we got a couple of different things that would happen there. All right, a negatively charged object is brought nearby two neutral metal spheres that are touching, and then they're separated. Okay, so we've got this negatively charged object. It's near these two neutral spheres, so I'm going to draw them neutral. Same number of pluses and minuses there. And so these two are going to become polarized because of induction, because of this negatively charged object coming nearby. So what charging method is this? This is going to be induction. Okay. So when we have our negatively charged object coming near, that's going to cause the negatives in this first sphere to move away, leaving less negatives on this side. Okay. And then I'm going to have negatives, because these two are touching, these negatives that collect up here are also going to move into this sphere. Okay. So we're going to end up with sphere A, okay, is going to be positively charged because it's going to lose, its electrons are going to move over to one side because they don't want to be near this. And then they're going to also move into this sphere because these two are touching in this first part. Okay. So sphere A is going to be positively charged because it's going to lose some electrons over to sphere B. Okay. which sphere has the greatest charge, they've still got the same charge. Like they didn't lose any charges. They just are distributed differently. Instead of them both being neutral, now this sphere has more electrons than this sphere. Okay. So for that, we're going to say neither. And we're going to remind ourselves about conservation of charge. They still have the same amount of charge. And charge is one of those things of the universe that gets conserved. You can't create more charge or destroy charge. It stays the same. It just moves around. Okay. Okay, a positively charged ball and a neutral ball hang from strings. Students observe that they initially attract, then after they touch, they repel. Okay. So when they touch, which direction did the electrons flow? So the electrons are going to go from the neutral over to the positively charged. Remember, the positively charged, it's positive because it lost some electrons. So some of these electrons in the neutral ball are going to want to go over to this positively charged ball because it has less electrons. Okay, so they're going to go from the neutral to the positive or positively charged. Okay. What are the charges after they touch? Okay, they're both going to be positively charged. The first object lost electrons. Okay, it's still got a loss of electrons, even though it takes some from the neutral ball. The neutral ball now has also lost electrons because it gave some to the positively charged ball. So both are going to end up positively charged. They're really just kind of sharing that loss of electrons. Okay. And then what charging method caused ball 2 to become charged? That's conduction, because they touched each other. Remember, conduction requires contact. Okay, I'm going to try and do one more on this. So the diagram shows a neutral sphere attracting a positively charged rod. Is the sphere most likely a conductor or an insulator, and why? Okay. Let's see. So it looks like this is probably some kind of insulator. It's going to be my guess because of the placement of the charges. Okay. So the negatives are moving over because they're attracted to this positively charged object. They're going to collect up kind of in one section, and then the rest of the sphere is still neutral. Remember, on the page before when we talked about insulators, we said if they get an imbalance, it's really just going to be in one section, either where they were rubbed due to friction or where they're close to another object, like here. This is induction. And then the rest of them is going to remain neutral. Okay, so I'm going to say this is an insulator due to the placement of the charges. And in this case, the negatives collect in one section. Okay, so we'll continue on the next one with the electroscope.